Welcome to the SolidCAM University channel. This video's topic is using a tool ball or setting up a tool ball. So a lot of the times when you've got a part such as this one, a welded part, there really are no flat faces on here. So when you've bolted it to your fixture and you have to machine a face on a weldment like this on an angle, let's say this face up here, there's really nothing here that you can trust to set up your coordinate systems. You can't exactly touch off on the top of that thing and then assume that you've got a nice flat face. So you might want to use a tool ball. So this part right here, you can see there's a little red slot right there, a little red pocket. That is basically where the tool ball is going to be put. So we're going to start from the beginning. We're going to actually insert the tool ball into this part. So we'll go to Insert Components, Tool Ball, and I've just got the tool ball connected to my mouse. As soon as I click anywhere in this empty space, it places it in this file, but it's not affixed yet. So we're going to have to actually add some mates. So we'll go up to Mate, and we know this thing wants to sit in that hole. So we're going to just add a mate related to the hole. I'm going to choose that cylinder right there and that cylinder, which automatically makes them concentric. But the tool ball is facing in the wrong direction. So I'm just going to change the mate alignment to the same side. And I'll click the green check mark to add that mate. So I can still move the ball, but I can only move it along that concentric axis there. I can still rotate the ball, and I can still shift the ball. So we need to add 2 more mates to this thing to fix it in space. So the next one, which should be pretty clear, is we're just going to choose this face right here and this face right here. And that will make them coincident, meaning that that ball can no longer pass through that face. This is the 2 of the most realistic of the mates. You know you're going to screw it in there, and you know it's going to stop on that face there because of the flange of the ball. But there's actually one more mate you need to add here. Because this thing is fully cylindrical, fully circular, you don't really see it unless you kind of turn this a little bit. But I don't know if it's coming through in the video, but this is still rotating. It's rotating about that concentric axis. So you actually want to go into the decision tree here, the feature tree, go to Tooling Ball, and choose something like the top plane. So the top plane is not something in real life that you'll see, but inside SolidWorks, this is something you can actually grab onto. And I want to make that parallel to this face right here. Now, again, in real life, that's probably not a true face. It's a welded part. It's a piece of sheet metal. But inside of SolidWorks, that is a true flat face. So I can use that for things like parallel mates. So with all 3 mates added, if I try and move this thing, it'll give me the message that the part is fully defined. And that's exactly where we want to start from. Okay, so I'll just click Save, and we've saved that change. So now, this thing would be sitting on a fixture plate at a certain angle. Hopefully you have the print that says what angle it's at, and you need to machine this face up here. Now, seeing as nothing on here is a true face, you can't really touch off on anything in here and know that you have your actual heights and all that. So we're going to use a tool ball for that. This face right here, let's say that it has already been machined. We know that is true, so the ball is sitting true. We're going to use the ball to set up our coordinate systems. So we'll just zoom in on the ball here. So we know that the top plane passes right through the ball. So we're going to use that as a sketch plane. So inside of a sketch on the ball, I'll go to Convert Entities, click on that arrow there, and go to Intersection Curve. Essentially, any face I click on, let's say the sphere, it will now create a curve that passes through that sphere, through that plane, the plane and the ball's intersection, essentially. So click on the green check mark, and that gives us that curve. Because it's a true curve, it actually also gives us the center point, and that's really the reason why I'm creating this first sketch. I just want that center point, and this is essentially the easiest way to get that. So top right corner, I will exit out of the sketch, and we have the center point of the sphere, and that's what I want. Because no matter where this thing sits in space, the center of the ball is always going to be the center of the ball, essentially. So if we change the angles to change the planes, we always will use the center of the ball as kind of a reference point. So if we need to machine on this face up here, I need to set my z-axis to be perpendicular to that face. And again, I don't know what the true face on the welded part will be, so I'm going to touch off on this ball. So let's go back to Assembly, Reference Geometry. If I click on this arrow and click on Plane, I now will create planes. So I know I need the z-axis to be perpendicular to that face, which essentially means the z-axis can be parallel to this face. So I'm going to click on this face here and say I would like the plane that I'm about to create to be parallel to that face. Now I want the plane to pass through the center point of the sphere, and that's why we created that first sketch. I just want to click on that center point there, and now we have a plane that passes right through the ball. Okay, so since we have that plane and it's currently highlighted, I'm going to click on Sketch, and we'll sketch inside of that plane there. And again, the reason we're doing that is because we need to have the outside edge of the sphere. This is what we're going to touch off on when we actually set up our part. So once again, I'll go to Convert Entities, click on that arrow, go to Intersection Curve, click on the ball once again, click the green check mark, and now we actually have a complete circle that completely tells us the outside of the sphere, and once again also that center of that arc basically. Okay, so since we have that, let's click the green check mark. So we need a line and a point on this curve here so that we can set up our z-axis. So let's go to line. In this case, I'm just going to choose the center line, and I want to choose the center point of the sphere to start. Because any one of these lines that I draw, any direction, we know that as soon as it intersects with the outside edge of the sphere, or in this case, this circle, we know we're going to get some sort of tangent point along the circle. So I'm just going to draw my line into space like that, and we'll just stop the line. So since it passes through the center of that circle, mathematically, any intersection point between this line and the circle is going to be a tangent point. Okay, so like I said, we need to know the direction of z, which is going to be parallel with that. So we're going to go up to, going to angle this a little bit, grab our line, and holding the Control key, I'm going to grab the edge of that right there. Again, inside of SolidWorks, we can assume that those lines are true. In real life, we can't really use that. Now, we have those two highlighted, and I'm going to add a relationship here where that line that I created is parallel to the edge of that surface. So that line right there could easily represent our z-axis for machining. But we're not actually touching off anywhere in space there. We're touching off on the ball. So I'm going to do a relationship between the endpoint of that line and the circle sketch. And I'm just going to say, make the endpoint of that line coincident. And by doing that, I've added an endpoint to that line that is actually on the tangent point of that circle. So in real life, when we go to touch this thing off with whatever kind of indicator we're using on our machine, we'll touch right on that point right there. That is the topmost point of this sphere at this angle. Okay. So with that geometry in place, we can go into SolidCAM. Let me just save this part first. Go to Tools, SolidCAM New, Milling. And we'll go to Coordinate System. It really doesn't matter what we choose under Place Coordinate System Origin because we're going to move it. But we still first need to orient the z-axis. So again, inside of this perfect SolidWorks model, inside the virtual space, I can still click on this face to orient my z-axis. But we're not actually using that as the origin. The origin is going to be on the Toolball. So I'll go back to the left side, click on Pick Origin, scroll down here, and there is our top of the sphere that we created with all those sketches. So I'll just say Pick Origin there. Now that I have that there, it's just a matter of setting up which direction is my X and my Y. So let's say, for instance, X positive is to the left of the screen. I'll just go to Pick X Direction. I'll choose this edge right here as the direction I'd like X to go. So X is parallel to that line, but it's pointing in the wrong direction. Well, I just have to go over to Flip Around Z, and now I have my X-axis pointing in the correct direction at the very top of the ball. Now, this is for this type of Toolball or any kind of setup fixture assistant, but essentially the idea is the same. You can use sketches and these various edges and faces of your part to set up this sort of thing inside of SolidWorks, SolidCAM, before you get onto the machine. Any questions on this or anything similar to this, you'll find in the videos on our YouTube channel, or if you need any help with anything else, you can always call us at 1-866-975-1115, extension 2. You can send us your parts and your questions via the ticket system at solidcamsupport.com, or stay tuned for the rest of the videos on this YouTube channel. Thanks for watching.